This is going to be a very informal session, but still, I would say keep a notebook with you or a digital notebook, notepad, anything you take a bunch of notes in to note down some points with you. So those are the two things, or maybe add some positive attitude to it. So you need some water or something to drink with you, a notebook, and a positive attitude to start the session. Let's start by some introductions. My name is Sadia Khaf. I am a PhD researcher at École de Technologie Supérieure in Montreal, Canada. And let's just say hi to each other. So if you guys would like, please turn on your video for a second and just tell us what's your name, what do you do, and where are you joining us from?
Hi, everybody. My name is Eduardo. Call me Edu. I'm also from Montreal, Canada. Yeah.
Welcome to the class, Edu, and really nice to have you here.
Thank you. Thank you for organizing this. Oh, I hope you don't mind. Maybe we'll have the room.
Oh, absolutely, absolutely. The more the merrier.
Thank you so much.
Hi, my name is Vincent. I'm from Montreal too, and that's probably it.
Thank you so much for joining. For some of you who don't know, Vincent is my husband, so thank you so much for joining.
I don't know what you're talking about.
I'm gonna mute my husband for the rest of the class because since we're in the same office, there is a lot of interference when both of us have our mics open and we are talking. So I'm gonna have to mute my husband for this and for other reasons for the rest of the class.
Vince, just wave if you need help.
Well, yeah, that we can do something about it. Okay, Damyun said, I have zero experience with coding. That's actually a good thing. When you don't have any previous experience with coding, this class will benefit you the most because this class is I designed it specifically for beginners or specifically for people who are just starting with any kind of coding because this is basically what I wish how I learned coding. I started with C++, I guess, as my first language, and the way I learned it is not the way I wish I learned. If I could go back to my undergrad, or if I could go back to before even a couple of months before my undergrad when I started learning, I wish I learned this particular way because the way different programming languages are taught at school is not really the ideal way in my opinion. They are focused way too much on syntax, they are focused way too much on a specific one programming language that they kinda don't teach you how to think like a programmer, how to be a programmer in the first place. So that's something that comes along after years and years of experience later. When you've been coding for a couple of years, that's when you develop a mental model, a mental system of how to think like a programmer, how to approach any problem when you're trying to code it. So the lack of that kind of formal education, that kind of a formal system that teaches you how to think like a programmer compelled me to keep this course focused more on how to code rather than going way too specific into Python. Of course, we will be using Python as our example to learn how to code, but this the introduction here is basically to teach you how to code in general. So it's actually a great thing if you don't have any previous programming experience because that means you will learn how to learn any programming language in the right way. If you get what I mean, rather than just moving from one language to another. This course is not designed to teach you how to switch from one language to another if you already know how to code, if you're already coding in one language. It's rather more for how to get started with programming and how to think in terms of a code, in terms of a program, and how to get started with writing it. And today's session will be quite introductory. We will just cover some basics. So if you already have some knowledge, and if you have something better to do, feel free to leave at any point you want. No grudges, nothing will be held against you. You can join the next session or the one after, which will be more advanced. Today's class will be pretty basic and pretty introductory. So let's get started with the basics, or what we are going to cover in this class. So as I said, I wanted to teach people how I wish I learned to code when I started. So that's why I'm gonna start with the first ever thing: how to think like a programmer. Thinking like a programmer doesn't mean thinking in terms of Python or thinking in terms of C++ or thinking in terms of C. Thinking like a programmer means that you will get started on paper first. You will not think in terms of any specific programming language. Also, learning a programming language just for the sake of learning it doesn't really accomplish anything. I remember a few years ago, I just wanted to learn Python for the sake of learning it. And on and off, I was checking random tutorials for about 6 months. Not very consistently, just passively, whenever I have some time, I was looking at some tutorials, but I didn't really learn anything in those 6 months because I didn't have a project to work on. There was no objective that I want to accomplish by learning Python. There was no practice involved. I was not writing code myself. I was not accomplishing anything. So I didn't learn Python at all in that time. Versus a few months after that, or maybe a year after that, there was something I wanted to do in my home. It was something related to building a local search engine for some photographs. I wanted to create a search functionality or something. I completely forgot what it was about, but I think it was an image search engine, I guess, and I wanted to build it on a Raspberry Pi or something locally. So to do that, I chose Python as my programming language of choice because I wanted to learn Python. Now that time, since I had a project in hand and I was learning specifically to build that project, I learned like this. Within a week, I became comfortable with writing code in Python. I built that functionality, whatever I was trying to accomplish, within a week. And things I learned during that project, I still use them today. Because when you have a goal in mind, when you have an objective in front of you, an assignment or a project that you're trying to accomplish, then you're Googling very specific things for it. You're implementing them right after you learn them. So if you don't implement Python in something, whatever you learn in this course, you will forget that like this. The moment you leave the course, you will forget it. Or if you have very, very good memory, you will forget it in a week. So it's no exaggeration. Trust me, I learned a lot of programming languages during my undergrad. I learned C, C++, assembly, Verilog, MATLAB, of course, VHDL, a bunch of others as well. At some point by myself, I also learned HTML, CSS, a bit of other stuff for my websites. I learned SQL. I learned quite a lot of programming languages during that time in the last few years. But I only knew them while I was working on a particular project for them. Afterwards, I completely forgot them. The only ability I retained throughout my life, which I haven't lost, is how to think like a programmer. I know my process. I know how, if I have a project to do, how I'm gonna go about it. Once you know that, the rest is just syntax. You can Google syntax very easily. If you can code something on a paper, you can translate into any programming language you want. So that's why I'm very, very focused in this code, in this program, in this course, to teach you how I think about any problem, how I go about writing my code, what's my process in the first place. So on this slide, you will notice that there's in the left or right, I don't know which side it is, but there is some red blocks. Can you see them? They're in the background. Can anybody tell me why I put that image there? What's the purpose there? How does the word perspective really relate there? What do I mean by that? Any volunteers? Anybody who has any ideas about this image? Tell me anything. Take a random guess. You guys are forcing me to pinpoint and put people on the spot. I don't like doing that.
I think they might be the start or end of a code. For example, a program I want to make.
Mm-hmm.
I make a pseudocode. I make a logic, and the blocks present the start and end point, or let's say input or output of that logic. And what goes inside is all the processing. That's what I.
Nice observation. Thank you for sharing with us. Anybody else who would like to relate it with the word perspective?
I think that they are separate code blocks because in programming, I think we can work on different modules separately and then we combine them together. This is how I perceive it basically.
Again, another very useful, very nice observation. Thanks for sharing. One more volunteer and then we will move on. One more volunteer who can relate it with the word perspective.
I'm seeing it kind of like a bunch of different blocks. So I'm imagining you're referring to the blocks of code and how they relate to each other.
True. How would you view these blocks? If you're viewing them from, let's say, another angle, how would they look?
I imagine kind of like you write a story, like beginning, middle, and you each have a finality to it, and you each have a beginning of it.
True, but let's go even simpler than that. Without even connecting them, without telling a story with them, without even connecting them. Right now we are seeing them from a side angle, right? Approximately at a 45 degrees angle. What happens if we just look at them from front? Like if we are not looking at this image, but let's say there is this wall with some blocks and perturbations coming out of that wall, and we just look at it from the front. What would we see? Would we see the depth of the blocks from there?
We could just see like squares if we're talking like that front thing.
Exactly. That's what I mean by perspective here. We will just see two-dimensional squares or blocks. We would have no idea about the depth of these blocks, or width or height, or whatever you want to call it. We would only see 2D blocks. But from this angle, we are looking at a 3D picture. If we take another view, for example, a top view, in terms of engineering, you know what a top view of the thing is. Front view, top view, side view. So basically, if I have my coffee mug here, I'm looking at it from this angle. I'm not sure if you can view my hand here. So what you see here from that angle is the front view. If I put my camera on top of the cup instead, whatever I see the coffee, the drink in it, that's called the top view. And if I put it on the side, left or right, doesn't matter, then that's the side view. So from all these three different views, there can be infinitely many other views, considering, you can put your camera anywhere around this cup at any angle. You will see a different view. And that's what I mean by perspective. That's how we go about problems. I want you to think about it for like 30 seconds while I sip my coffee. That's the first thing a programmer does. When you approach a problem, you cannot look at it from one particular viewpoint because you're only seeing a limited point of view from that angle. You cannot limit yourself to just seeing the top view of the problem or the front view of the problem or the side view of the problem. The first thing a programmer does is look at the problem from different angles, from different perspectives, from different sides. That tells you what should be your right inputs, what should be the output of your code, what should be the processes involved in your code. But you have to look at your problem, whatever you're trying to accomplish, from at least more than two perspectives. Ideal would be like look at it from like 3, 4, 5, as many as you can perspectives. But the first step is when you look at any problem, you want to build a search engine, look at it from at least 3 or 4 perspectives. If you want to build a honeypot, as my friend shared with me, look at the problem from at least 3 or 4 perspectives. Think about it in terms of different viewpoints, different angles. What would it look like? What would be the inputs of this problem? What would be the outputs of this problem? What do I really want to accomplish with it? Is there another way I can go about it? Before even thinking in terms of the solution, just sort of think in your head, what would your code look like? What would your problem, the end product, look like from different perspectives, from different angles? After that, think of a solution. Okay, this is now the standard framework of a programmer. What does a programmer do? Looks at the problem from different perspectives, thinks of a solution, tries that solution. Now, what are the possible outcomes of that solution? 99.99% times, the first solution is always wrong. If you're really lucky, it would work. If it does, great. That's the end of the story. But if it doesn't, then what do you do? What do you do? What do you think of if it doesn't work? You wrote a code, you tried a solution, you wrote a code, and it doesn't work. What comes to your mind? Anybody? I need volunteers, people. I need a lot of volunteers in this course.
Look at it from a different perspective and try a different solution.
Absolutely. That's what we do. We think in terms of what went wrong. We see if we can do anything about it. Is there anything else that I can try? Is there any other solution that I can try? If the answer is yes, great. We think of that solution and we do it. We implement it. We keep working in this loop until the answer to does it work is yes. That's our terminal state. That's the word great there. That's our terminal state here. Once we tried a solution that worked, we went to the terminal state, great. If it didn't work, we think again, is there anything else I can do? If there is, I go back to it and I try another solution. I keep doing it until I find a solution that works. That's the programmer's framework. Can anyone tell me what's wrong with this framework?
That's stuck in a loop.
Absolutely, it's stuck in a loop. But if you never find a solution that works, would you spend the rest of your life trying to work on it? And the answer is no. If you've exhausted all possible solutions, the step, anything else that you can try, if you've exhausted all in a limited state space, if you've exhausted your options, if you have tried a bunch of solutions and it doesn't work, maybe it's time to quit. Because as a programmer, it's important to find solutions, but it's also very, very, very important to know when to give up. That's something we are taught not to do as often as we should be, because most of the time some problems are just not solvable. So it's very important to know when to quit. It's important to know how much time you want to allocate to a problem, how many times you want to try a solution, and if it doesn't work within that, then fine. It's fine to give up on projects midway. It's not a loser attitude. There's actually a very good book about it. The writer mentioned a quotation that really resonates with me, that quitting is not for losers, it's for winners. Because you have to know when you need to quit. If you're not enjoying your job, if you're not enjoying your code, if it's not useful enough anymore, it's very, very important to know when to quit. So that's the general programming attitude that you can apply to basically anything in life. You can apply it to relationships, finance, home renovation, and anything that's going on around you. Thinking like a programmer means that you look at every problem from different perspective. You try a solution. If it works, great. If it doesn't, you try another solution. You keep trying until either you find a solution to the problem or you've exhausted your resources. You've exhausted your thinking process. You've exhausted everything you could have done about the problem. So that's the general framework that you should be applying to every problem in your life. thinking like a programmer. Because when you develop this habit of thinking like a programmer, that means you can solve all the problems in your life, or you will be sure that you exhausted all your resources. You get what I mean? So basically, that's basically all about thinking like a programmer. One last important thing. When you have a problem, you have to break it down into very tiny steps, like Lego blocks. If you want to build a honeypot, you won't start by thinking, I want to build a honeypot. You will think, what do I need to do to build a honeypot? Or if you want to build an image search engine, you won't start by thinking, okay, how do I write the first line of code to build an image search engine? No, you won't do that. You will break it down into very tiny steps. You will break it down into Lego blocks. And those steps won't look like this builds an image search engine. Those tiny Lego blocks will be something like storing a variable somewhere, creating a condition somewhere, creating a loop somewhere. So those are the building blocks, and the building blocks of every programming language are almost similar. Once you've broken down your program, your approach to your code into tiny Lego blocks, and you've written down on paper what those Lego blocks are, then you can build them up using those Lego blocks, a programming language is nothing more than a glue that binds those blocks together. So if you have the blocks on paper to do any problem you want to solve, because you have to start on paper, you can't just open a compiler right away, start writing your code, start building it, because that's the wrong approach to programming. First of all, you always have to go back to basics and you have to start on paper. Think about the problem you want to solve. Think about the steps involved that will be required to solve this problem. Break down those steps into tiny Lego blocks until those blocks look something like create a variable, store a value in it, create a loop, repeat this action X or Y number of times. If this happens, then do this. Otherwise, do this. Once you're on paper, your code looks like that, then a programming language is just the glue that you will use to build those blocks together, to bind them together. That's why the language is somewhat irrelevant in the process of coding. Yes, certain languages are inherently more useful for certain types of tasks than others. Just like a wood glue is more useful for woodworks versus it might not be as effective on ceramics or glass or something else. So yeah, different types of glues work better for different types of objects you're trying to create. But in the end, the function of all of them is just gluing things together. That's the function of a programming language. It just glues your Lego blocks together. Your Lego blocks are the important part. And that's what you should be focusing on. You need to learn how to break things down into Lego blocks. And then learning the syntax, learning the language will take you just like a few days. Learning the syntax will be so simple, so easy for you that you will just Google, because what's the problem with programming languages that seem difficult? What's the problem when you're stuck in a project? What happens? You're Googling stuff like how to build a honeypot. It looks very complicated because it's someone else's process. Someone else has divided it into tiny blocks and built it according to their Lego blocks. But when you want to build something from scratch for yourself, for your own purpose, and you have your own Lego blocks, then you won't be Googling overall how to accomplish a project. Then you will be Googling the right questions, which would look something like, if Python is your language of choice, the questions would look like how to store a variable in Python, how to create a list in Python, how to write a for loop in Python, how to implement conditional statements in Python, because you have your Lego blocks. You have your framework. You know that, okay, this block goes there, from the output of this block, if this, then this, otherwise this, then take this action 10 times. So once you know those steps, then you're Googling the right questions, how to write a loop, how to write a conditional, and that just means that it makes the language, the syntax, a lot more easy to learn for you. So if you know how to solve a problem on paper, you can code it. All that said, in this course, the resources that we will be using are 3. Can you tell me what those resources could be? We need something to code. So if you have any experience trying to learn Python, the first step becomes so difficult that a lot of people give up just there. You have to download. Do I go with Anaconda? Do I go with Jupyter Notebook? Do I go with Visual Studio Code? Do I go with just Visual Studio? What do I need to download to start coding in Python? So some of you who already have experience with Python already know the struggle, deciding between what platform to use, what compiler to use, what tools to use, what text editor to use. It becomes a nightmare, to be quite frank with you. And we're going to use a tool that solves that nightmare, that solves that problem. By doing what? Writing Colab in our browser. So I want everybody, all of you, to go to your browser and open Colab. Google Colab. Oh, I need to sign in with a different account. Google Colab in your browser and go to colab.research.google.com. Open it right now. Let me know when you've opened a browser tab and you have Colab open with you. You will have the welcome page. Okay, Arham says done. Everybody else, I need to know you guys are following when we are actually starting to code. Perfect. So this is the first resource that we are using in this course. It's called Google Colab, and that eliminates the need to download anything to get started with writing Python code. You can start right now. For example, go to this line that's already there. This first block, after the getting started part, there is a code block there that says seconds in a day, 24 times 60 times 60, and then just write seconds in a day just so it prints it on the line. When you click run button, it gives you the answer right below it. And right now, can you tell me if you guys have done this? Like if you guys have clicked run on this and... Okay. Yes, ran it. Yes. Okay. Congratulations, you just wrote your first Python code. That's how easy it is to get started with Python. You open a browser tab, you write some text that makes sense to everybody. What are we doing? We are just calculating how many seconds are there in a day. There are 24 hours. In each hour, there are 60 minutes, and in each minute, there are 60 seconds. So we are just multiplying those numbers just like a calculator, and it's giving us the answer of however many seconds there are in a day. That's the first Python code you just wrote. Now, what's the thing that's called seconds in a day here? Why did we write it 2 times in this line of code? Seconds in a day here serves as a variable, and we will go into the details of data types, variables, other stuff just in a bit. But just to give you an example of what you just did, now the value of these things, it's stored in this thing called seconds in a day. That's called a variable. It's stored here, and if you just create a new code block by clicking on code, and here, if you write seconds in a day and just run it again, and by the way, to run it, you can either click this, and if you're on Windows, you can also just click Control Enter, or if you're on a Mac, I think it's Command Enter, and it will run the code. Go ahead, try that. So this is your variable. If you want to, now since this value is stored in this, we can manipulate it. Right now the value has 86400. Let's just add something to it. Let's print maybe this plus 1 and run it. That just increments our value by 1. So basically, we just learned that in Python, this is how variables are created. No particular syntax. You just write a word and you store with the equality sign. You just store a number in it, and after that you can just perform basic operations on it without any special needs. No commas, no semicolons, nothing of that sort. You have a variable, you write +1, it does a +1. Okay? So far so good? Stop me at any point. Anytime you want to ask a question, you can turn on your mic and you can stop me. Anywhere, anytime during the class. So this is the first resource that we will be using as our platform of choice. Where are we coding? We are coding in Colab. You can go ahead, bookmark that in your browser, or you can note down the link somewhere, note down the name in your notebooks, whatever you have to do, note it down. The next resource we are using. Does anybody know what's GitHub? Other than people who have programming experience. Anybody else? Someone who doesn't have any programming experience, can you tell me if you've heard of GitHub? Okay, Edu knows. Edu, I'm getting more and more impressed by your programming knowledge for someone who says I don't have programming experience. So GitHub, go to github.com. GitHub is a collective code repository of a lot of programmers in the world who are coding stuff and then putting it out there for other people for free to reuse their codes. People write their codes and then they publish it. So you can publish your codes privately as well as publicly on GitHub. That way, it makes it very easy to share your code with each other. If you're working in a team, 2 people can work on the same code together, and GitHub makes it very easy. For example, if I've updated something in my code, I can store it to GitHub right away from my keyboard. And if someone else is working on the same code, when they open their GitHub, they will see that I've made a change and they will move forward from that point. So it makes it very easy to collaborate as well. But just for personal use, it's a great place to look at other people's codes. For example, if I show you my own repositories, my own codes, these are some of the repos that I have. I think you can't see it right now. Okay. So the first one that you see over there, multi-agent reinforcement learning for cognitive radio, MARL for cognitive radio. This is the code for my last paper that I published. It's publicly available, anybody can reuse it. Second one, IEEE hands-on RL using Python. That's actually a very, very good place for you to get started. So if you want to go to my GitHub, you will go to github.com/Sadia Khaaf. You see there? Like you will go to github.com/Sadia Khaaf, and all of my public repositories will be visible there. So if you want to get started with machine learning using Python, the second repo that I showed you, which is this one, IEEE hands-on RL using Python. This is a workshop I delivered. You can find the link in this repo for my entire workshop, which was, I think, posted on YouTube. If you have time, you can watch it. It's an introduction to Python as well. Not introduction to Python, it's for people who already know Python. So later on, when you know Python, you can, and you want to get started with machine learning, you can go there. It's an introduction to reinforcement learning. I used a Q-learning code in this example. I used OpenAI Gym in this workshop. So you can bookmark this for later use when you know a bit of Python. For your own codes as well, you can Google how to use Git, how to integrate it with Colab, and how to store and share your codes for easy access with others. I would suggest everybody in this class to create repositories and share with the other people in this class. So whenever you're working on a project, whenever you're trying to write some code, you have help from each other. So if you have a tiny assignment that you're trying to do, you guys can always share your code with each other and work together on those projects. So whoever wants to create and always have a project in mind that you want to accomplish after learning a language. So create your projects. At the end of the course, I will also be reviewing your codes. You can get help from me if you get stuck. So I highly suggest that use these two resources. Have Colab, learn how to integrate by just Googling it, it's just a couple of steps. Learn how to integrate GitHub with Colab, and whatever you write, whatever notebook you have in Colab, save it in your GitHub as well, and make it a public repository so that even if your code doesn't work, still keep it public so that you can have feedback from other people in class. You guys all have emails of each other, no? If you don't, I will share your emails with the class so you guys can easily collaborate with each other while you're learning this. Okay, the next resource we will be using in this course is called W3 Schools. That's another highly useful resource for you. Google W3 Schools, go down to Python tutorial. This is something we will be coming back to again and again during this course because that's the easiest place to learn basic Python. We will be using it as sort of our course material. We will be learning from it. So learn at your own pace. You can come back to it anytime you want. You can bookmark it in your browser or just note it down in your notebooks. It's a great resource. I would not suggest trying the code here in itself because that means you're not saving your codes anywhere. Although you can run it here and it will just open a new window and you can write your codes there, you can save them. What I would recommend is if you want to try any code, copy that from here, go back to your Colab, create a new code block, and once you have that code block, paste it there and then run it there. So that way, whatever you're pasting and trying in your Colab notebook, you can save it in your GitHub, you can share it with others, and you guys can work together. So these are the three resources that we will be using in this course throughout. Colab, GitHub, and W3 Schools. Now, moving on to the building blocks of Python, or building blocks of rather any programming language. Can someone tell me any three building blocks of any programming language? Any three. You can name anything. Any volunteers? Volunteers. I don't like sleeping classes. This question is more for people who have a little bit of programming knowledge, who have coded in other languages before. Variables, functions, conditions. Thank you, Zara, for letting us know. Anybody else?
Loops.
Loops, absolutely. Absolutely.
Arrays, maybe.
Arrays, yeah. In data types, absolutely. Comes under variables in the end. Okay, perfect. So, as some of you guessed, we have variables, conditionals, and loops. In any programming language, those will always be the building blocks. Other things built on top of them. In variables, you store stuff. Just like in our example, we created a variable called seconds in a week, and we stored a value, seconds in a day, and we stored a value in it. That's our first building block. Variables are like that X in algebra, where you can store any variable. Let's create an X. For some reason, I really like the variable X. It keeps showing up again and again throughout our math. Let's say X is equal to 20. And then we run it. After running it, we create another code block and we print it. For printing it, you just write X and it prints the value that is stored in X. Now, instead of this, if I go and create another code block, for that too, you can use the shortcuts. If you want to look at what shortcuts you can use to create these new code blocks or text blocks, when you hover over it, you will see what are the shortcuts. I always keep forgetting them, so I need to come back to them and look at them again. If we say now X is equal to 10 instead. And right there, if we print x, now x is 10. So variables are places where you can store a value, change a value, and you can update their value as well. Instead of just doing this, if I added x is equal to x plus 2, what would be the value in x now? Anybody? I'm sure everybody guessed it. That's now 12. So variables are places where you can store some numbers, manipulate those numbers, perform some mathematical operations on them, and the values get updated. In Python, code gets executed line by line. So the first thing that got executed in this code is line 1, which was x is equal to 10, which means store 10 in x. The second thing that got executed is x is equal to the previous value of x plus 2. So this new value, the previous value was 10. 10 plus 2 is now getting stored in x. And now we are printing x. What happens if I do x is equal to, I am a variable called x. And this is another important distinction between Python and some other programming languages. There is no explicit data type declaration necessary in Python. What do I mean by that? Previously, we stored this number in x. So x was a number, which means it was an integer number. We could store float numbers in it. We could store anything in this that we want. There are no explicit data types in Python like some other programming languages. You can store in your variables strings, lists, arrays, tensors, anything you want. We will get to the details of those as we progress in this course, but the point is, even though x was a number before, in the new line, if I say x is a string, and this thing is called a string in Python, or you can just say it's a line of text. So this whole line of text is now x. And you can perform operations that are performed on lists or strings on this particular variable now. Okay, for now that's enough about variables. The other building block that we have are conditionals. And what are conditionals? Conditionals are what we saw previously here. This thing, when you come to a block that has a yes or no answer, that is a conditional. Does it work? Yes or no? If this works, then go here. Yes, do something here. Or if this doesn't work, then go here and do something. The branching out is basically conditionals. Branching out of a code. Your code started here, let's say x is equal to 10. Then you say if x is greater than 5, then come here, do some operation here. Otherwise, if x is not greater than 5, if it's something else, you come to this code branch and execute this code here, do something here. So this if else or if then else kind of thing is called a conditional. And that's another very, very important programming concept, because conditionals let us do branching in a code. So you have certain values and you can put certain types of conditions on it. So conditionals are the second thing that we will be learning in this course. We have some variables, we have some conditionals, and we will learn how to do that in Python. For example, in Python, it's very, very simple. Let's say I want to create the example that I did. I said x is equal to 10. Then I want to write if x is greater than 5. And here a little bit of syntax is involved. When you're writing conditional statements in Python, they need to be in a bracket. There needs to be a colon in it. And when you press enter, you will see that the code is not starting at the same indent level as the previous line. It has 4 more spaces or a tab than the previous code. So here I can say print x is greater than 5. And now I want to do the other branch of my code, the else branch. So I write else. Oh, sorry. Can you see it now? Thanks for letting me know. My bad. And here I can say print oopsie doopsie x is less than 10. Okay? So if I run this code, what happens? Since the value stored in x right now is 10, which is greater than 5, this code gets executed, but this one doesn't. So if we go back to our example of the branching of a code, here you stored the value 10 in x, let's say in the first block. Forget the text in the blocks right now. Suppose that in this block I wrote x is equal to 10. Then I came to this block where I'm trying to make a decision. I said here, is x greater than 10? Greater than 5. Where did I go from that branch? I came here and then I wrote some code here which was saying that, okay, print x is greater than 10, and that got executed. The other code will only get executed if the answer is no. For example, if we go back to our code screen, can you see my code? And we change the value here and we make it 4 so that it's less than 5 now. And we run this code again. So now it says oopsie doopsie x is less than 10. So that's how conditionals work in any programming language, in Python, in other languages. Conditionals basically are the branching out of code. You have one block, then you have a condition that says if this, then do this, otherwise do this. So that branching is called conditionals. There are multiple types of conditionals. Just if else if, multiple conditions, or if then else. They're all in the end conditionals that branch out your code into different processes. Okay? The last idea is loops. And that one we will cover in next class. We will cover in details if else as well as everything else in the next class as well. But this was basically just an introduction to how to get started with Python, what platforms we will be using, and what are the basic building blocks. Quickly, can anybody tell me, anybody without a programming experience, what could be loops? Before we end the class, can anyone tell me what could be a loop? Anybody who doesn't have programming experience, as well as Edu, because Edu, I don't believe him that he doesn't have a programming experience anymore. So someone other than the people who have any programming experience, what could be a loop? We implicitly did discuss it in this class.
Is it when in the other diagram where we were looking at the solution and we went back to the start?
Absolutely. I was hoping someone would say that. So exactly when you came here and you went back there and you're stuck in a loop. So when you're doing things again and again a certain number of times until either a condition is met, or if we just said that, okay, do these actions 10 times, a repetition is a loop. So there are 3 actions here. Try a solution, does it work, blah, blah, blah. Any kind of thing that we are doing multiple times, that's a loop. Any action that we need to take, let's say we need to increment x, we need to do x plus 1 10 times. We can do it instead of writing x plus 1, then again writing a line x plus 1, then again writing a line x plus 1. We can do it in a loop and run that loop 10 times, which does x plus 1. We will discuss more about it in the next class, but this is basically all for today's class. Now let's see if you have any questions and we can discuss those. Let me know if there was anything that that you found helpful, if you found anything not helpful, not so clear. Any questions that you have, let me know. You can write them in the chat or you can just ask me. Now I'm looking at the chat and seeing if you have.
I would like to know about the content and how we will proceed with the course.
That is a very good question. I will make it next week and send it to everybody. Because so far I only prepared first class. I did not plan the rest of the content yet. But the rough outline would be W3 schools. If I go back to my... Okay, so you see W3 schools here, and you see these things on the side, which are kind of like the outline of this course. We won't discuss advanced topics like file handling or modules, or maybe a little bit of matplotlib because we might be plotting some stuff. So this can serve as a general outline of the course. And depending on the pace of the course, depending on how everybody is picking it up, we can make it faster or slower. So that will basically determine the total number of classes we will have. So this can serve as a general outline of the course. The things we will be covering in the next class are the variables, data types, casting, strings, boolean, basically all of this we will cover in next class. Plus we will also cover if else, while loops and loops. So the second class will be the most intensive one. We will cover variables and loops in the second class. And after that, in the third one, we will start moving on to further down the list. I think in total, it will take maybe 5 or 6 classes at most to teach you everything there is to know about Python. Okay, who asked a question? Do we have a space where we can communicate regarding the course and classes and keep up to date? Well, I will share an email thread so you guys can have the emails of everybody, and you can then choose a platform. You guys can either make a WhatsApp group or maybe just an email thread, whatever is your preference. Someone from the class can volunteer to choose a platform and add everybody else to discuss it. But so far, personally, I haven't created any class group yet, but I will share your emails with everybody. Okay, let me actually open the chat fully because I'm missing some questions. Can you explain about W3 Schools? W3 Schools is an excellent learning resource for multiple languages. Personally, for me, I used it for Python, I used it for SQL. These are like mini tutorials with examples to teach you any language very quickly, very easily. Can you share the applications of Python in different fields of programming, and where did you use it in your life? Personal, you shared, and professional. Well, professionally, all of my work right now is in Python. I am a machine learning researcher in my professional capacity. I'm doing my PhD in machine learning. It's about the applications of wireless communication knowledge to cognitive radio networks. Cognitive radio networks is about improving the internet connectivity in future, where, if you have a certain amount of bandwidth, let's say, and you can only connect 10 IoT devices, mobile phones, laptop, computer, that kind of stuff, that can all have a good internet at the same time. In future, once I implement my machine learning algorithms on that bandwidth, then it will be able to handle up to 100 devices, giving them the same level of bandwidth, same speed, same everything, by applying machine learning and optimizing the use of bandwidth. So that's my PhD about. This is called cognitive radio network. So that's where I'm applying Python right now. You can check out my paper if you like. You can just go Google my name, Sadia Khaf, Google Scholar. Or just write my name, and I think the first thing that shows up will be Google Scholar. And here you will find my papers. My last paper was partially cooperative scalable spectrum sensing. So this is my work about, and this is where I applied my knowledge of machine learning. And the code for this is available in my GitHub. Okay. Oh, thank you. My pleasure. My pleasure. Also, I applied some of my knowledge when I was teaching back in Pakistan. When I was in Pakistan, there's a university called Ghulam Ishaq Khan Institute of Engineering, Sciences and Technology, GIK. I taught there for about a year as a lecturer, and there I also used some Python for another one of my paper. The other papers here are with my colleagues from that university here. So yeah, I use Python for quite a lot in my life. Okay. Anybody else with a question or anything you want to say before we close this class and this session? Feel free to open your mics if you guys have a question or if you want to say anything.
If we are interested in the advanced parts like pandas, NumPy, deep learning, machine learning, and how you handle the data frames and that perspective. So this is not targeted for this specific course, right?
No, this is not targeted for machine learning. This is specifically for getting started with any programming language. And we are using Python as an example. But I can try to make a presentation or a course or point you to the resources you can use to learn NumPy, TensorFlow, PyTorch, Pandas, how to handle data frames and stuff. I would say start with my machine learning repository on GitHub that I shared, the IEEE hands-on one. Let me just show you again. If you go to github.com/Sadia Khaf, in my public repositories, you will see this this particular one here. So this one is basically, sorry, this one is the repo that I used for a workshop. And I think in this, I'm not sure if you have a link to my YouTube video in this. Yes, you do have the link to my YouTube video also in that. So in this particular one, you can open this and you can check the workshop. In that one, I basically used Q-learning as an example to teach how to get started with reinforcement learning.
Thank you for the explanation. I will check them out.
My pleasure. If that's all, actually that's all from my side. I will share your emails after the class with everybody else and see you in the next class. Is the same time okay for next week for everybody, or do we need to select a different time? If this time doesn't work for you, let me know if you want to change to another time. Yeah, I think we will keep it once a week, because we can make it twice a week if you guys want, but it would be a little bit difficult for me to have both Saturdays and Sundays, because on weekend, here's my schedule. Weekdays, I work on my PhD. Weekends, I have French classes from 1:30 to 4:30, but I have a half an hour travel time to get there. So on my weekends, I leave home at 1 and I come back by 5. So Saturday and Sunday, I have French classes. So on Saturdays or Sundays, like one of these 2 days in the morning, same time, I can do Python classes. Both of these days would be a little bit more hectic for me. Saturdays are good? Okay. So see you again then next week, same time, and hopefully you learned something from this class.
Thank you, Sadia. See you. Bye.
My pleasure. Bye.
Bye-bye.
Bye.
Bye.